Hello, this is Dr. Hooper continuing our series of webinars. This webinar is 2B, recorded in March of 2019. It's entitled Environmental Mold and Mycotoxin Testing, and it's the introduction to testing. The first question that we would want to go back to looking at in the first webinars is being our own advocate. And the question that comes up is, why should we choose RealTime Labs' toxigenic mold assessment over anybody else's? Well, probably because there aren't too many others to pick from, and RealTime Lab is one of the premier laboratories who do this type of work. It's unique in its ability to adequately assess the threat to your health from exposure to these molds and the mycotoxins they produce. RealTime can detect the presence of toxigenic infectious molds in indoor environments. They can detect the presence of mycotoxins produced by these toxigenic molds, and they can test the occupants for the presence of mycotoxins using its clinical mycotoxin test. The critical questions that we want to ask are the organisms found in the home pathogenic, or are they toxigenic? In other words, if they're pathogenic, are they disease-causing? And the second question would be, what if any mycotoxins are being produced? Now, we can't ask that of most of the DNA testing that's done because, as you can see, the ERMI testing tests 36 organisms. We'll go through this, and most of those have not been identified as pathogens or disease-causing in humans. And so the ELISA test that we are going to be talking about does pick 10 of the most pathogenic organisms, and we discuss those. So the historical availability to you as the patient and the client for mold testing is a list made here called air sampling. They do spore counts, they do tape lifts, and they can do bulk sampling or cultures. The newer concepts in testing are ERMI, that is put out by EPA, the HERTSMI 2, which is a documentation of really looking at the ERMI test, and then environmental mycotoxin and mold assay that is put out by RealTime Lab. The EPA stand and the documentation on air sampling is and has been in the literature for a long time. In most cases, EPA says if visible mold is present, the sampling is unnecessary. Now, I differ with that documentation because some of these molds may be nothing, non-pathogenic, and others are. There is no EPA or other federal limits that have been set for mold or mold spores, so sampling cannot be used to check a building's compliance with federal mold standards. Now, this is EPA's stand on things. Surface sampling may be useful to determine if an area has been adequately cleaned or remediated. Sample analysis should follow analytic methods recommended by the American Industrial Hygiene Association or the American Conference of Government Industrial Hygienists, or any other professional organizations. And one of the things that the EPA talks about in their discussions is an Anderson sampler. We're not here today to talk about air sampling, but these are the guidelines EPA does give. So what are the federal regulations regarding mold testing? The EPA states that standards or threshold limit values, TLVs, for airborne concentrations of mold have not been set. And currently there are no EPA regulations or standards for airborne mold contaminants. And this is out of the EPA's booklet 402K, and you can find that on the website and read about it. Another procedure is the tape lift procedure. And they use tape, so they get a piece of absolutely clear, not frosted tape, that is 1 or 2 inches in length and 3/4 inches wide, and then they handle it by the ends only, and they position the adhesive tape over the suspected area and press firmly. They remove the tape from the surface, place it onto a clean microscope slide, and then put that in a box and send it to the lab. The lab then looks at it. It can stain it if it wants, but the stain will go underneath that tape, or they can just look at the tape. And they count the spores. So there's another process. They use spore traps and spore counts. The spore trap objective is to capture and quantify a broad spectrum of fungal spores, both culturable and non-culturable. So they can suck these air samples through a spore trap, and then the spores stick to this a piece of filter paper. The advantages: they're capable of capturing a majority of spores and particulate matter in the air. And they can also be used to quantify pollen, fiberglass, high-fold fragments, hair, skin, etc. The disadvantage is most mold spores have a unique morphology and are identified by direct microscopic exam, and some do not and are more difficult to identify. This latter type must be counted in broader spore groups, and that's why when you look at the results, you'll see Aspergillus / penicillium, because they look so much alike under the microscope. And they can't also entertain or assess the viability of these spores. Spore counts give an indication of the mold spore count inside the home compared to outside, so that's why you always have to have an outside error and an inside. They're subject to errors due to the wind outside, but can give a fairly good indication of the inside spore numbers. It's very important if the occupant is asthmatic or allergic, but it can generally have little meaning to the clinicians or to the patients. You must tell what mold is present and if it's a toxin producing to be much use. That's RealTime stand, that's most MD stand, and that's because if there's a diabetic or immunosuppressed patient, some of these organisms can cause severe disease processes and affect these patients. So the spore trap non-viable methodology is reported by these counts, and you can see that they've circled penicillin and aspergillus here because they look so much alike, and then they give it a number of spores per cubic millimeter, and that's what they use to compare to the outside versus the inside and tell if the patient's house is contaminated or not. So other procedures to determine mold in the environment, which are older techniques, the bulk sample, they take a big huge amount of drywall or whatever, and they remove 1 or 2 square inch piece of the suspected material, place it in a clean plastic reclosable bag, and send it to the lab. You can do swabs, and that they're a last choice for when the sampling area is difficult to reach. A bulk sample is not practical, or the surface is very wet, and a tape sample will not adhere to the area of concern. So a swab is somewhat useful. The wipe samples should only be used if sampling is not possible by any of the above methods mentioned. Wipes should not be preferred method of sampling unless there's a proper justification to do so. So now let's go make sure that we understand these are the older techniques. This has nothing to do with the DNA testing that we're going to do or talk about. Laboratory tests on samples obtained from buildings now that are the newer ones are the ERMI, which is the Environmental Relative Moldiness Index, the HERTSMI-2, which is an acronym for Health Effects Roster of type-specific formers of mycotoxins and inflammagens. Say that 3 times fast. And EMA, which is Environmental Mold and Mycotoxin Assay. The ERMI test we're going to discuss first. What is ERMI? It was developed by EPA to assess water damage history of a building. It measures 36 different mold spores. 26 are found in water damaged homes and 10 are not. And they are put on separate sides of the result sheet. They were originally comparing the two to develop an ERMI score. The ERMI score was developed as a research aid and was not developed to be used in final analysis, which it has been over the years. It does not measure mycotoxin production, which is a critical indicator of potential health hazards. So how is the ERMI done? It's a DNA-based technology. Mold-specific quantitative PCR, or qPCR, is used to measure the concentrations of 36 indicator molds in floor dust samples. And we talk about floor dust, but it can be any kind of dust. And what results are obtained with ERMI? So we're going to come back and talk about that in a minute. But HERTSMI-2 comparison is a little different. It's a mold test that analyzes the dust sample provided for 5 molds. These molds are known as the Big Five. HERTSMI-2 differs from ERMI testing in a few ways. It looks at 5 molds. ERMI looks at 36. The ERMI gives the results as an easy to understand the comparison to an established database of water damaged buildings and non-water damaged buildings. Remember I told you the 26 and 10? As the HERTSMI-2 analysis for 5 molds is done, it is cheaper to do the analysis compared to 36. And which mold species are identified in HERTSMI-2? Aspergillus penicilloides, Aspergillus versicolor, Chaetomium globosum, Stachybotrys chartarum, and Wallemia cbi. Of interest, the most prominent organism that is a killer to many patients in immunocompromised patients, either cancer or transplant, is Aspergillus fumigatus. And the HERTSMI-2 score doesn't have Aspergillus fumigatus in it. When you're determining the HERTSMI-2 score, they give 10 points depending on what the spore count is. And you can see these spore counts, and you can get these from us, or you can get it off the website when you look at HERTSMI-2. And they give 6 points for around this if they're lower units of spores, and then they give 4 points if they're even lower. And then they interpret the HERTSMI-2 score statistically safe for re-entry is anything less than 11, and anything greater than 15 is dangerous, don't enter. What's most concerning to me is that the Aspergillus fumigatus and some of the other pathogens that aren't listed in the HERTSMI-2 are just bypassed by people, and they let them go back in the house even if there's 10,000 spores of Aspergillus fumigatus, without questioning the clinical history of the patient. The EMA is the test that is offered by RealTime Lab, and it's a laboratory test in 2 parts. It has PCR, or polymerase chain reaction, testing DNA for the presence of 10 most pathogenic fungi, and then it does 15 mycotoxins, which are associated with human symptoms and illnesses. This is a list of the organisms in the EMA test and its relationship to mycotoxins, which we have labeled. The G is gliotoxin, A is aflatoxin, C is citrinin, and then there's stegmaticin, macrocyclic trichothecenes, ketoglobicin, fumonisins, etc. And we're going to talk about these in later webinars. The mycotoxin ELISA test recognizes 4 groups, and then of these 4 groups there's 15 different antigens, and aflatoxin is the most carcinogenic group, especially B1. Macrocyclic trichothecenes, there's a list of 9, and the gliotoxin, which comes from Aspergillus fumigatus. The next slide shows how we do this, and the ones that we detect as well. The structure of these organisms or these toxins are very similar to the structure of a hormone. So a lot of the patients have hormonal issues as well, and that's something that we'll talk about as we get into the specific mycotoxins later. There have been warnings from the experts that the experts talk about these environmental exposures. In 2009, the World Health Organization said that mycotoxins, endotoxins, beta-glucans, and other volatile compounds in the indoor air are a concern, but an excess level of any of these agents in the indoor environment is a potential health hazard, and they wrote that in 2009. In 2004, the Institute of Medicine of the National Academy of Sciences stated that in vitro and in vivo studies have demonstrated adverse effects after exposure to specific toxins. And that's bacteria, molds, and other products. So be knowledgeable of these experts. They're saying what you know already. CDC has said fungal disease poses an important threat to public health for several reasons. Opportunistic infections such as Cryptococcus and aspergillosis are becoming increasingly problematic as the number of people with weakened immune system rises. So using the ERMI test, real-time lab frequently detects Aspergillus fumigatus in water-damaged homes. That's why we put Aspergillus fumigatus on our EMA test. And we also put another newer organism on here called Candida auris that is isolated from Africa. It's also isolated from southern or South America, as well as southern U.S., and it's very resistant to antifungals and can cause a severe disease in patients who contract Candida auris. So we're going to discuss that in a later webinar as well. So what real-time lab provides to environmental inspectors are the following: DNA testing to determine presence of 10 most toxigenic species of mold, and these are the pathogenic molds as well. It offers environmental testing for 15 mycotoxins, most commonly found in water-damaged homes. Its toxigenic mold and mycotoxin assessment can be discussed more by calling the lab or the sales rep for a price list. There is literature for customers to describe tests and compelling reasons to buy it. We are getting ready, Real-Time Lab is getting ready to publish the results of their findings, and we can train the environmental inspectors on mycotoxins and toxigenic molds. The chain of custody we expect to have filled out properly is listed here, and you can ask Real-Time Lab for the chain of custody. It's very similar to the ones you're familiar with in filling out for other environmental tests, but you must say what you want to order, and we're not mind readers. Questions again are present here through Real-Time Lab. You can get our address. You can go look at us on Real-Time Lab, Facebook and Twitter, or go to our website of www.realtimelab.com. Please feel free to contact us at any time. Thank you.